Good morning, Noah. I am looking at your chapter 7 that you just turned into me, number 9, and calculating total resistance in amps in a parallel circuit. And I noticed you don't have the right answers in there. So here's a little explanation about that. So I'm just going to draw out the first one. Hopefully you can see this good. So here's our power source. It goes up, and then they want you to check A1. Well, I'm going to call that I1 instead because it's really calculating amperage, and the symbol for amperage is I. Then we go and we've got 3 paths. And it tells you that this one is 500 ohms, 500 ohms, 1,000 ohms. And it's giving you in these paths that you can calculate what they call A2, A3, A4. But we're going to call it I2, I3, I4. And then they've got over here when it returns A5, but we want to call it I5. So I don't remember if you were in class yesterday, but we decided to change those symbols and make it a little bit easier. So let me explain this. Electrons leave this battery source and they're traveling this way. There should be a certain amount of electrons right here. And once they get over here, some are going to go this way, some are going to go this way, and some are going to go that way. And we said electrons flow the path of least resistance. But only so many can go each path. So this is a really easy path. Boom, this is an easy path. This one's a little harder, so less are going to go over here. But eventually they all come back down here and they all got to come back together. So these two, I1 and I5, should be the same amount of electrons as long as we don't lose any. Like anything, once in a while you're going to have one jump off the conductor, and we could lose an odd one here and there, but we shouldn't lose very many electrons. So I'm going to just leave this here for a second so you can look at it. And now I'm going to show you how do we calculate total resistance in a parallel circuit. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. That's the equation we use all the time. So now we just got to plug in our numbers for this equation. So 1 over RT, 1 over, and if we look at number A, or 1 over 500, plus 1 over 500, plus 1 over 1,000. Well, if you want to add fractions, you must find a common denominator. So my common denominator, when I look at this, is 1,000 multiplied top and bottom by 2. Because you learned a long time ago, Mr. Loger, probably in 6th grade already, maybe in 5th grade, that anytime you multiply a number by 1, you're not really changing its value. 2 over 2 is 1. So now we're going to go 1 over RT equals 2 over 1,000 plus 2 over 1,000 plus 1 over 1,000, which is really going to equal 5 over 1,000. And then we do that thing called cross multiplying. So we have 1 RT equals 5 over 1,000. We cross multiply and we get 5 RT equals 1,000 times 1, which is 1,000. Divide both sides of this equation by 5 to separate the variables. So 5 divided by 5 is 1, so that's gone. RT equals 200 ohms. So in that first blank spot on that table, total resistance for this first circuit is 200 ohms. So you want to write that in. 200 ohms. So I'll leave that up there for a second so you can get a good look. You can pause the video. Now it wants you to find I1. Well, I1 is where it first comes off of the power source. So we're going to say I1, which they call I1, is E divided by total resistance. Well, our E, or our voltage for this circuit, it says is 100 volts. And you calculated it. Total resistance would be 200 ohms. (100) divided by 200, 0.5 amps. Total amperage in that circuit. Then A2, or we really want to call that I2, is going to be E divided by R1. So we're calculating the amps in that one path. Once again, E is 100 volts. And it's 500 ohms on that one path. So 100 divided by 500 is going to be 0.2 amps. A3, which is the same as I3, equals E divided by R2. 100 volts divided by 500 ohms equals 0.2 amps. And now if I look at A4, which we're going to call I4, I'm going to take E divided by R3. I'm going to take 100 volts. Whoops, excuse me. Divided by 1,000 ohms would equal 0.1 amps. And then what we're going to do for I5, or they call it A5, we're going to take I1 plus I2 plus I3, which is 0.2 plus 0.2 plus 0.1, and that equals 0.5. And then we said all along at the beginning, A1 should equal A5, or I1 should equal I5. 0.5, 0.5, and they do, and you know you did everything right. So now what you need to do is just go back and reapply that to B, C, and D. And I hope that helps you.